There are three basic trigonometric functions. So when we talk about trigonometry, of course, we're talking about tri, which means three-sided shapes or triangles. Trig functions for short. And those three functions are called sine, cosine, and tangent. In mathematics, we take the first three letters of each as a short form, and that gives us sine, cos, and tan. These are operations, which means that they are operations performed on a number, and that number is always an angle. So let us take an unknown angle and call it x. If we draw a triangle, and in this case it must be a right triangle, we'll talk about other triangles in another video. Here's our right angle, or 90 degrees there. Recall that if we decide to label this angle as x, that the side opposite is usually called big X. Similarly, if we take this angle y, the side opposite is called y. Now, for the purpose of making it simple, we're simply going to label the opposite side to angle x as OP for opposite and AD for adjacent, or ADJ, I suppose. Let us call that the adjacent side. Now, this side here, of course, being the long side opposite the 90-degree angle, is also known as the hypotenuse. I don't know what you're thinking, but Dr. Ling, the hypotenuse is also adjacent to x. Hypotenuse is special, we leave that aside. So, when we're talking about angle x, we talk about the side that's adjacent to it, which is not the hypotenuse. Sine x is now designated as the relationship or the ratio of the opposite side length divided by the hypotenuse. So if we say, for example, I'm making this up, say the opposite side is 3 centimeters long, and say the adjacent side is 4 centimeters long. Well, we know from Pythagoras that a squared plus b squared equals c squared, so hypotenuse in this case will end up being 5 centimeters. Sine x is now the length of the opposite side, opposite over hypotenuse, which is 3 over 5. So we have 3 centimeters divided by 5 centimeters, which equals 0.6. People often ask me now at this point, what happens if we make the triangle bigger? Now, the lengths are different, so is sine different? So for example, if we make this triangle bigger, does that change opposite divided by hypotenuse? No, it does not. If I were to make this triangle effectively bigger, let's say instead of 4 centimeters, let's say it's now 4 kilometers long. Let's say this is now 3 kilometers long. Let's say this is now 5 kilometers long. Well, yeah, effectively the triangle is bigger, but the angle x is still the same, and the proportion between this opposite side and the hypotenuse stays the same. Therefore, the 0.6 does not change, neither does the angle. Same thing works for cosine. Cosine of x is designated as the ratio between the adjacent side divided by the hypotenuse. So we have adjacent divided by hypotenuse, which in this case turns out to be 4 divided by 5, giving us 0.8. As long as this angle stays the same, so maybe it's 30-some degrees, then the cosine of that angle stays the same regardless of how much we magnify the triangle. Because the different parts of the triangle stay the same in relation to each other proportionally. For example, if I took you and put you into a scientific shrinking machine, the size of your head would still be the same in relation to, say, the size of your big toe. Your hands would still be the same size as each other regardless of whether I shrunk you up to 10 times normal size or shrunk you down to microscopic size. My hands would still be the same proportion to each other. So it is with this triangle as well. Tangent of x is defined as opposite over adjacent. So we take the opposite side divided by the length of the adjacent side, and we get 3 divided by 4, which of course is 0.75. An easy way to remember all this is to take opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, and we come up with sine OH, cos AH, tan OH, giving us the letter SOH CAH TOA. If you remember nothing else, remember that. If we take the sine of y, we will notice that the side opposite to y is the same as the adjacent of x. So the sine of y would be this side here, opposite over hypotenuse, which in this case is 4 over 5. So we can see, if you're really thinking, that the sine of this angle here is the same as the cos of this angle here. But that is a topic for the next video.